My dear friends, welcome to Rajashekar classes on applied data science with Python. This is lecture number 358. In this lecture, we will try to understand differentiation in the context of solving optimization problems. In machine learning, the most important ideas of calculus which are most often used, the basic differentiation. We use both single variable differentiation and vector differentiation. This is not very complex. This is very simple. We will mostly use the concepts of maxima and minima. We will do a quick recall and understand the basics of differentiation and maxima and minima, because these are key ideas in optimization. 99%, I can say 99% of data science, data science optimization, I can say 99% of data science optimization depends on these two ideas. What are these two ideas? Ideas like differentiation, maxima and minima. Of course, there are some other ideas like integration and differential equations. Some of you might learn these two. These are less used. Problem is integration and differentiation, these are less used, seldom used in data science or machine learning. Most oftenly used basics of differentiation and how to compute maxima and minima. We will give a geometric intuition behind everything, because understanding optimization is very important in understanding data science or machine learning. A lot of data science algorithm based on this optimization techniques. For example, PCA, logistic regression, linear regression, even technique like support vector missions, for which understanding optimization and basics of differentiation is super duper important. Having said that, let's go and dive into understanding differentiation. First, we will see a single variable calculus, very simple single variable differentiation. Let's assume, let me consider a simple function. Just see this one. Let's assume this is, just observe this particular graph. This is my x, this is my y equal to f of x. Here y equal to f of x. Let's assume I have function like this. This function y equal to f of x. Let's assume a function looks like this is just for simplicity. This could be any function. Just I'm assuming a simple function. Imagine differentiation often written as, just try to recall your primary classes, how you used to write differentiation. Differentiation often written as dy by dx, isn't it? It is also written as df by dx, y equal to y because y equal to f of x. Even people used to denote it as y dash or even sometimes f dash. What this means is differentiation. What is this dy by dx? Differentiation of y with respect to x. That's what this means. Before we go into differentiation, what does differentiation means? What does dy by dx means? Intuitively, what does it mean? Dy by dx, what does it mean? Dy by dx intuitively What does it mean? Let's understand that. Let's take a point x1. Just let me consider here a point x1. I am considering point x1 here and another point x2 here, other point x2. So now differentiation intuitively means the rate of change. How can I say? It is rate of change. What is this rate of change? We will try to understand intuitively. What it means is how much does y. I can say how much does y. Just I am writing here. Just see how much does y changes as x changes. That's what it intuitively means. Basically, rate of change of y with respect to x. We can also think of it as rate of change of y as x changes or with respect to x. Let's understand what it means first. That is, which is important, isn't it? Suppose I have 2 points x1, x2. I have one point x1 and another point x2 which are closed. Let's correspondingly for x1 correspondingly there is a point y1 and another point y2. Here y1 equal to, what is your y1? y1 equal to f of x1 and your y2 equal to f of x2, isn't it? It's simple and straightforward. We know what is x1, what is x2, we know what is y1, what is y2. Let me assume this is, what is this? This is distance between x1 and x2, isn't it? This is distance between y1 and y2, isn't it? Let me assume this as right angled triangle. Just I am writing here the same triangle, I am writing right angled triangle, isn't it? What is this difference? This is y2 minus y1. Just I am writing here y2 minus y1. What is this difference? x2 minus x2 minus x1. Let's assume, what is the angle here? Let's assume this is angle theta, isn't it? Let's assume this is theta. Now if I say how much does y change as x changes, what does it mean? Given this right angle triangle, this is my right angled triangle, given this right angle triangle, given this information, if I have to say how much does y changes as x changes, I can write it as y2 minus, I can write it as y2 minus y1 by x2 minus x1, isn't it? What is this y2 minus y1? How? Because this is how much, this is numerator is how much y changes, denominator is how much x changes. That's what I am saying. Dy by dx intuitively rate of change of y with respect as x changes, isn't it? So this rate of change of y, which is often written, this particular term y2 minus y1 by x2 minus x1, it can be often written, just see this, that's what it says. Just see this one, y2 minus y1 can be written as delta y and x2 minus x1 can be written as delta x, assuming x1 and x2 are close, not very far away. This is, what is this delta y by delta x? What does it mean? What is the meaning of delta y by delta x? What does it mean? This is rate of change of y with respect to x in the vicinity of x, isn't it? In this, how can I say? Now, what is this delta y by delta x? This is nothing but tan theta. What is tan theta? This is y2 minus y1 by x2 minus x1. That is delta y by delta x. So intuitively, this is what it means. Now let's go to mathematics formulation. Mathematically, what it means is, how can I say? So mathematically, dy by dx is nothing but, what is your dy by dx? Dy by dx is, how can I write? Just see, mathematically dy by dx is limit delta x goes to 0, delta y by delta x. Let me explain what it means. What does it mean? So the derivative of y with respect to x or differentiation of y with respect to x is the rate of change of y with respect to x as the change in x tends to 0. You must assume, I must say like this, derivative. So the derivative of y with respect to x or differentiation of y with respect to x is the rate of change of y with respect to x as the change in x tends to 0 or change in x is very small. So let me assume this is my x1. What is this? This is my x1 and this is my x2. If x2 comes closer and closer to x1, that's important. Here your x2 comes closer and closer to x1 only, then my delta x, if x2 closer and closer to x1, then your delta x goes to 0. As x2 comes closer to x1, my delta x becomes 0 or tends to 0, becomes closer to 0. Now x2 comes closer to x1. What happens to this particular line? This line, the blue line, just see this blue line that we see here eventually becomes, that particular blue line eventually becomes tangent. It is tangent of f of x. I can say tangent of f of x at x1. So what is the tangent? Tangent is the line that touches my curve exactly at one point. This is called, just see, you will get a tangent, isn't it? This is tangent, isn't it? This one is, I can say this is called tangent. Now since we said tangent is a line, remember tangent is a line is hypotenuse. Is it not hypotenuse? Yes, this is called hypotenuse, this one, isn't it? This tangent is hypotenuse for our right. This is called that we obtained this. How we are getting this hypotenuse? We obtained as delta x goes to 0. Now this line tan theta is nothing but dy by dx. I can say what is tan theta? Here tan theta is dy by dx, isn't it? Tan theta is nothing but dy by dx because theta is what I got. As delta x goes to 0, delta y by delta x becomes dy by dx, isn't it? Which implies that tan theta becomes my dy by dx. The geometric interpretation of differentiation is nothing but, I will read for you, geometrically dy by dx is same as it is the slope of the tangent to the function f of x. Is it not? What is this? This is basically it is slope of f of x. So if you want to compute the tangent at given point x1, people often write it as dy by dx. First, what is dy by dx? Slope of the tangent to f of x. Dy by dx at x1 is slope of the tangent to f of x at x equal to x1. That's what literally differentiation is measuring. The most important thing is the whole of differentiation and integration are invented like 1600 years by two phenomenal mathematicians. What are those? Who are those phenomenal mathematicians? One of them is one of them in how can I say? One of them is they were independently created or invented by Newton and German mathematician named Leibniz, isn't it? There is a mathematician, German mathematician Leibniz. Unfortunately, we don't remember Leibniz as much as Leibniz as most of the symbols like integration, the symbol integration. Just you might have seen the symbol integration. The symbol is introduced or created by Leibniz. Most of the calculus we use today is Leibniz calculus. Even the same ideas were arrived at by both Newton and Leibniz independently. Of course, Newton's mathematics, if anybody has read Principia of Mathematica, just what is this book? This just say Principia of Mathematica. Both Newton and Leibniz both independently invented differentiation and integration, solving problems like what is velocity, acceleration, what does gravity means, what are the orbital paths. To answer all these, we need rate of change of things, because acceleration is rate of change of velocity, velocity is rate of change of displacement, isn't it? What is velocity? So velocity is essentially, velocity is the rate of change of displacement, and acceleration is rate of change of velocity. So most of the calculus we use today is actually created to solve physics problems in the late 1600 and in 1700. This is almost 400 years old, or 300 plus years of old, but we still use it to solve machine learning or data science problems today. That's the beauty of the calculus. It's probably one of the greatest creation of humankind. If I have to put it that way, if I pick one great idea in whole science, I will pick the differentiation, one of the top-notch ideas in the whole of mathematics. It is so fundamental to many things we do. It is taken granted today. Without calculus, nothing would have actually happened. What is this tan theta? What does it mean? Tan theta. Theta is the angle between tangent and x-axis. That you must understand. What is this theta? Theta is the angle between tangent and x-axis. Now let's understand tan theta. Let me assume this is my x-axis and this is my x-axis, this is my y-axis. Which one is tangent? Let me assume this is my tangent. Which one is? This is my tangent, isn't it? Now, how does tan theta looks? Just try to recall your preliminary classes. You might have learned the shape, this geometrical shape of tan theta, tan x. This is a tan x shape. How does tan theta looks? This is important to note. Tan theta follows a graph is like this. If 0 less than theta less than 90, what is your tan theta? What happens if your tangent looks like this? How does tan theta looks? Tan theta is, what is tan theta? If your tan theta is, if it is 0 less than theta less than 90 degrees, your tan theta is positive, isn't it? If your tangent looks like, let me assume your tangent is like this, isn't it? Tangent, what is tangent here? This one is tangent which is parallel to, this is, let me say, this is tangent which is parallel to x-axis. So tan 0 is 0. Tan theta is nothing but slope. You have the positive slope. If 0 less than theta, positive slope. When you have positive slope, if 0 less than theta less than 90 degrees, isn't it? Suppose if you have curve, if you have curve like this, this is the tangent, isn't it? This tangent is parallel to x-axis, which means angle between both of them is 0 degrees. So tan 0 equals 0. Now what happens if you have curve, just if you have tangent like this, just see, if what is this? This is 90 less than theta less than 180, your tan theta is negative, isn't it? Then what does it mean? For example, if you have your tangent like this, for example, this is my tangent. If this one is tangent to you, then what is the angle between this particular tangent and x-axis? What does it mean? This is my if this is my tangent which is perpendicular, which means tan 90 is undefined, isn't it? Tan 90 degrees is undefined, isn't it? Undefined and is not defined. If you see tan 90, if it goes to plus infinity, isn't it? Here, so it is not defined. There is a discontinuity of the curve at 90 degrees. Just go back and if you go back and see the tangent curve, just see here, there is a discontinuity at 90 degrees, isn't it? Now what happens if the next interesting case is you have x-axis here? Let me say here you have x-axis, just see here you have x-axis and y-axis here, and what if your tangent is here? What about tangent? If your tangent is like this, what is the angle between this tangent and x-axis? What does it mean? This is your tangent, isn't it? This is your tangent. Here theta 90 less than theta less than 180 degrees. Then tan theta. What is your tan theta? Tan theta is negative. Slope of this is negative. What does it mean? Tan theta is negative means slope of this is negative. This is negative, isn't it? Yes, it's a negative. Well, so intuitively I can summarize all of these in single plot. Let's try to summarize all of them in single plot. For example, if you have a plot like this, let's take a plot like this. It looks like parabola. This is what is my x here, what is my x here, this is my x, this is my y, isn't it? Slope here will be here. What is the slope? Here slope will be positive, isn't it? If you take this, what does it means? If you take this angle between this between this line, between this angle between this particular tangent and x-axis is less than 90 degrees. If it is less than 90 degrees means what is your tan theta? Tan theta is always positive, isn't it? Here, what about here? It's the angle between this particular tangent and x-axis as it is this particular slope is, I can say, negative. What about this particular point? This is tangent. This tangent is parallel to x-axis. Therefore, theta equal to 0, isn't it? Theta equal to 0 means tan 0 equals 0. Angle here. What is the angle here? What is the angle here? Here angle is greater than 90 degrees, isn't it? Angle between this particular tangent and x-axis greater than 90 degrees and less than 180 degrees. Slope here is negative. What is slope here? Slope here is negative. What is the slope? Slope is nothing but tan theta. What is slope? Slope means I can say slope is nothing but tan theta, isn't it? This is one diagram where you will get whole idea of slope very easily. Having learned the basic geometry, what I understand, we understood the geometric interpretation of what is differentiation is. Now let's look at very simple rules of differentiation. Some of you might already know these rules. Just let me recall these rules. These are simple rules. What is this? D by dx of x power n is nx power n minus 1, and all these simple rules you can always recall all these things. Here I don't know if some of you know about this phenomenal engineer called Jeff Dean. He is one of the most engineer at Google Brain. So one of his recent conferences, he made one beautiful statement. What it says, all deep learning or all of modern machine learning is just chain rule, because deep learning is cutting edge of machine learning right now. All modern deep learning algorithms is applying chain rule. Just go through this lecture. If you have any difficulty, please keep a comment. Thank you very much.